Hey guys, so today for you I have Leetcode problem 129, which is sum root to leaf numbers. So basically what you're doing is you're given a binary tree and it only contains digits in each node from 0 to 9, so only under 10, so every number can be represented with one digit. And you're supposed to look at every single path from root to leaf and say that's a value, and you're supposed to add up all those values. So for example, here you'd say 1, 2, that's 12, 1, 3, 13, 12 plus 13 is 25. So in here, you'd say 495 plus 491 plus 40, and that equals 1026, so you return 1026. So I have a little bit more complete example. Sometimes examples don't really cover a lot of the kind of edge cases. So this both of these examples together, they have a node with a left and a right, a node with neither left nor right, and but they don't really have a node with only a left, a node with only a right. So I kind of drew a little bit more thorough example to kind of look at all the edge cases. This only has a left. I guess I don't really have one that only has a right, but okay, well, it doesn't really matter, I guess. Only having a left and only having a right, it's kind of the same thing. So in my example, you see I have 1, 2, 4, 124, 1, 2, 6, 1, 1,261, and 189. And a couple things you might want to think about is, what if you have a 0 at the top? Well, then you'd have 0, 2, 4, which is just 24, so that could be an issue. And if your root is null. If your root is null, I guess your sum is 0, but it's just something good to think about. So what you kind of have to do here is, I'll show you what the Leetcode function looks like. So Leetcode just gives you this. It gives you some numbers, and you're given the root. So given just a root, it's kind of hard to keep track of everything. I mean, I guess you could do a depth first search and do it that way. So you'd go 124, okay, that's a leaf, add it to a running total, then you get rid of the 4, and it's kind of annoying. So what instead you can do, I guess it's still kind of a depth first search. You can look at, okay, so you start with the 0 and you just keep track of your running sum. So you say 0, okay, now I have a 1. And then you say, okay, now my total will be the total of my left plus the total of my right. So 12 plus 18. And then for the 12, you say, well, the 12, you go 1, 2, 4 plus 1, 2, 4, 6. And then you look at the 4, you say, okay, that's the end of it. It's a leaf. So you stop. And then for the 6, you say, okay, 1, 2, 6. And then you say that equals 1, 2, 6, 1 plus 1, 2, 6, null. So the null is, you can kind of just think about it as returning a 0. If you're looking at a null, you return a 0. And so yeah, so I will show you a couple things I've created, a couple functions already. So the first thing, like I said earlier, you're going to want to do is check if the root is null. So if the root is null, you can just return 0. Oops. Else, you can return, I created a little helper function that'll keep track of your current sum. So sum numbers help with your root, and your current sum is 0 because you don't really start off with anything. So our sum numbers help. So first thing it'll do is it'll calculate kind of a new sum. So it'll say your new sum is equal to your add. I created another function that'll it'll take your old sum and a new number and it'll calculate a new sum. So add number to sum, your current sum, and your root.value. So how this add number to sum works is, so say we have 12, we're at 12 already, and we're trying to add the 4. So we have 12 and you have a 4. So you want to get 124. So you want to take your first number, multiply it by 10, and add your second number. So you'd get 120 plus 4 is 124. And note, this would even work if you started with a 0 here. So if you have 0, your current sum would be 0. And then if you add a 2, it would give you 0 times 10 plus 2. And it just gives you 2. So what we can do here is we can say return sum times 10 plus number. So we create our new sum, and then we want to know if it's a leaf, because if it's a leaf, then we're done. So we'll check if it's a leaf, and to do that, if it doesn't have a left and it doesn't have a right, then it's a leaf. So we can return root.left equals null and root.right equals null. So if it's a leaf, then you can return your new sum. If it's not a leaf, what you could do, you could check, well, is the left null, is the right null, and that would be perfectly fine. It might even be perhaps a little bit more efficient than the way I'm doing, but you can just return the left and the right and check I'm sorry. So you can just look at the left and the right. So if you have 1, 2, 6, you can say 1, 2, 6 plus 1, 2, 6 plus the value on the left, which is 1, 2, 6, 1, and then it'll check its left and right, and then it'll say, oh, we're done, so we'll return 1261 plus 1, 2, 6, and then 1, 2, 6 plus the helper on, you can put 1, 2, 6 as the current sum and then give it a null root, and it can just check if it has a null root to just return 0. So else we'll put if root is null, return 0. And because of this, we can actually get rid of this check. If it returns in 0 and current sum will be 0, you'll still get 0, which is kind of the correct answer you're looking for. So you can just get rid of that. Okay. So you can just return new sum. You can return sum numbers help root.left new sum plus sum numbers help root.right new sum. And that should be sufficient. So I will let us look at both of our code and our kind of picture at the same time. So we're given the 1. We our tree node root, so we'll return root, and our current sum is 0. So if our root is null, return 0. We create our new sum, which is our add numbers to sum function, which multiplies your current sum by 10 and adds your values. So we multiply 0 by 10 and we add 1. So we have 1. Then we check if it's a leaf. So the 1's not a leaf. So it's not a leaf, so we return our sum num helper function. So we return it with our this node, with our 2 node, and our current sum is 1, and with our 8 node and our current sum is 1. So when this function gets called, our current sum is 1. It calculates a new sum. So it'll say 1 times 10 is 10 plus 2, it gives us 12. It checks if it's a leaf, it's not. So then it returns the answer of, it returns this node with 12 as the current sum, plus this node with 12 as the current sum. So when it evaluates this node, it says, okay, our new sum is 12 times 10 plus 4, 124. It checks if it's a leaf. It is, so it just returns 124, and that's where we get this 124 right here. And when we had the 12, it was returning the 124 plus whatever this side, whatever we get from this side. So you have 12 and 6, so 12 times 10, 120 plus 6, 126. You have 126, so then you'll add, you'll use this node, the 1, 126 in the node of 1, so that's 1260 plus 1, plus the 126 and the null, but when we put in the null, it just returns 0. So we just get, we don't even calculate our new sum. So even though our current sum was 126, because our root was null, we just return 0. So we get from here, it would return us 1261 plus 0, so it's just 1261. And so this side, it returned us 124 plus 1261. This side, it'll return us, it has their current sum that's 1. It looks with the node 8. 1 times 10 is 10 plus 8 is 18. It says 18 with the 9 node. 18 times 10 is 180 plus 9, 189. It looks at the null node. It says, well, null node just return 0, so it returns this thingy, returns 1289 plus 0 back to the 1, and the 1 returns whatever you got from all of this plus whatever you got from all of this. So the 1, it will return 124, 1261, and 189. So let me just run this code to make sure everything works properly. So, compiler error. Line 34 root. Oops. Happens. 25. So we'll submit. Well, it's good to run before you submit, and it's accepted. We'll check our details. Runtime. So we beat pretty much everyone. So I guess that's an optimal solution. Thank you guys for watching. I hope you all enjoyed.